Okay, so now we're going to do the CD nozzle with a shock. So we'll make a new fluid flow. Import same geometry as before. CD nozzle. Once again, change this to 2D. Design modeler. Generate. Very nice. So it's here. We can close this. Open meshing. Alright, here we go. So same as before, right click mesh, insert sizing, select this, boom. We'll do 0.01, so we won't take too long. And then we'll generate. We're going to wait for that to finish. Okay, so we have now our mesh finished. Same as before, we're going to go to edges, select, and then create named selection. This is our inlet. Hold control when you select multiple things, by the way. All of these, walls, and outlet. So we'll double check. We have our inlet, our walls, and the outlet. So we can close meshing, right click, update. Alright. Now we can go into setup. Same as before, double precision. My computer is fine with 4 processes, so I'll do 4. And then all of this is going to be the same, except for the boundary conditions. So same thing, we'll check. All of our volumes are positive. Looks good. And then same as before, we have our second x coordinate, which we need to note for our center line. So that's 10.11 about. So we'll go here, density-based solver. We'll go into models, turn energy on. Everything else should be okay. Materials, air. Density, change it to ideal gas. Close. Oh, let's actually make sure that I did change create. Okay, then we close it. We'll double check that that worked. Yes. Boundary conditions. Inlet. Let's change this to pressure inlet. Oh, okay. So same as last time. We're going to have 212, 886. and then 200 kilopascals, 200,000. Same thing, thermal will stay at 300. And close. Now outlet is going to be different. So as mentioned in the last video, if we use the A by A star ratio of 2, our back pressure for perfectly expanded case is 19.996 kilopascals, or around 20. So if we want a normal shock in the nozzle, we're going to raise our back pressure to be a little bit higher than that. So we'll do 25 kilopascals, or 25,000. And then the thermal for that will be around 173. And that is all based on the A by A star of 2. So one change, we're actually going to change this back pressure value. We're going to make it a bit higher. We're going to do 48 kilopascals. And then temperature as well. And then everything else should be good. We have our energy on. Ideal, perfect. So I think that's it. We're going to initialize. Okay, and then run for 500 iterations this time. It shouldn't take too long to finish. And then we'll come back when this is done. Alright, so we have finished the calculations. So we're going to go down to contours again, right click new, Mach contour, and then we'll start velocity, Mach number. So as we can see, we have a shock at towards the end of the nozzle. So right here we have Mach 2.08, and then we hit the shock and then we drop back to subsonic around this 0.6 to 0.8 region, and then exit the nozzle from there. If we go to new contours and then we do pressure and then select everything, same as before. Now we have the opposite story. We have higher pressure at the start. It drops very low and then it hits the shock wave and it spikes up again. And then we have density. Here. Once again, same story. Follows the same general trend as the pressure. We go to properties, sound speed, or speed of sound, close. We go. And then contour is new. We have Mach number, pressure, normal velocity. We haven't done that. And then the last one is temperature. Temperature. And there we go. Alright, so that's all of our contours done. We'll go to plots, XY plot, new. And then same as before, we're going to create a new surface line, and then use that same X value from before, 11, and we'll call this again sensor line, and then create. And then it's the same process. Pressure, we're going to do just the center line. Plot. And then as we can see, as expected, we have the initial pressure, 200 kilopascals, a steep drop off as it goes supersonic, and then a huge spike during the shock wave, and then a little bit of a kind of level off at the end. We can create the same for velocity. Center line. And then boom. So kind of the same story. Increases, drops down at the very end to the shock wave. And then next we have density. There we go. Speed of sound. Go to properties, sound speed, center line. Temperature. Plot. There we go. And then Mach number. And velocity, Mach number, center line, and plot. And so as we can see, after that shock wave, we're dropping down to Mach 0.64. So from around Mach 2 to Mach 0.64. So that is the case with the shock and the normal, or a shock and the diffuser. And that is everything. Thank you.